Pathak, Professor Gross, and all of you, the distinguished attendees. I'm indeed very glad to participate in this conference on flourishing in the age of disruptions and innovations through learning. The pace of changes in our world has increased thanks mainly to technology. It is fair to say that the only constant for us is change. Most of these changes are coming from the developed countries, the newly industrialized countries, and from China. India has been busy absorbing these changes and adapting to them. A constant theme in India is the lack of professionals who have the education to solve our societal problems and who are able to use modern technology for the betterment of our society. Therefore, this conference is timely. Education is learning to learn. Learning is the ability to extract generic inferences out of specific instances and using these inferences in solving new, related, unrelated, and unstructured problems. An educated person in a field has the ability to go into a new, unstructured situation in that field or even a related field, ask meaningful questions, and suggest some approaches to solving the problems posed by the new situation. The ability to use what one has learned generically in the classroom to solve new problems in related or unrelated fields is the key to learning and to the success of any education system. He does not have to memorize. Learning helps him broaden his horizon, his or her, obviously, improve his judgments, instill critical reasoning, enhance his curiosity, walk the untrodden path, reach the hitherto unattained goals, solve problems around him, and solve the future problems of the society. Let me take a simple example from statistics and explain what I mean by learning. Bayes' theorem is stated mathematically as probability of an event A given that an event B has happened is equal to probability of B given A multiplied by probability of A divided by probability of B. For example, let PA be the probability that a patient entering a clinic suffers from a liver disease. Let P be the probability of finding alcoholics in the incoming patient population at the clinic. The probability of finding alcoholics among patients with liver disease is therefore probability of B given A. The probability of an alcoholic patient suffering from liver disease is therefore probability of A given B. The first three are collectible data items and the last one is unknown. That is, you want to find out what is the probability of an alcoholic patient having a liver disease. Our problem is to better estimate this unknown using the first three knowns. That's what we call in statistics the a priori and posterior probabilities. What are the learnings from this particular example? First, it teaches us that we can improve the probability of an unknown by collecting related new information. The new information in this particular case is the probability of alcoholics among the patients entering the clinic. The question we want answered, and that happens to be the unknown, is the probability that an alcoholic patient that enters the clinic has a liver disease. Let us assume that a clinic maintains records that 12% of the patients entering the clinic indeed suffer from a liver disease, that 4% of the incoming patients are alcoholic, and that 6% of the patients with liver disease indeed are alcoholic. Therefore, PA is 0.12, PB is 0.04, and PB of B given A is 0.06. Bayes' theorem estimates that 18% of the alcoholics, that is because of PB given A multiplied by PA divided by PB, is what gives you PA given B. Therefore, 18% of the alcoholics who come in to the clinic as patients have liver disease. Thanks to Bayes, we now have a more accurate estimation of the chances of detecting whether an incoming alcoholic patient has liver disease, and that is, we have improved the probability from 12% to 18% now. Earlier, before we collected these three data items, we could only say that 12% of the patients coming to the clinic are likely to be alcoholic. Now, thanks to Bayes' theorem, thanks to the fact that we have data on alcoholics among the incoming patients, we are now able to improve the probability by 50%, from 12% to 18%. This is the learning from Bayes' theorem. What are the generic learnings from Bayes' theorem? The learnings are: new related information can enhance the estimation of probabilities of an event. Second, the ability to identify three information items or probabilities that are easily collectible. In this particular case, the percentage of incoming patients of the clinic suffering from liver disease, the percentage of incoming patients being alcoholic, and finally the percentage of patients with liver disease who are alcoholic. And finally, the last learning is the ability to better estimate the unknown. We can use this theorem to estimate better the probability of fire when there is a smoke. We can estimate better the probability of a patient with a positive mammogram actually suffering from cancer. We can estimate better the probability of rain when it is cloudy. It can help us better resolve false positives. It can be used in statistical quality control. It can be used in spam filtering, which you and I use in our email, filtering based on certain keywords, and in many other situations. As at a generic level, the ability to solve similar problems in myriad situations totally removed from the liver disease example is what learning is all about in this particular case. That is the ability to use what one learns in one's classroom to solve a problem in the real world and make our society a better place. That to me is learning. Let us look at some glorious examples of independent thinking emanating from such learning and leading to fundamental research and its applications. Quantum theory, invented by Max Planck, Albert Einstein, Niels Bohr, Werner Heisenberg, Wolfgang Pauli, Erwin Schrödinger, Richard Feynman, and others, is what has made transistors, lasers, magnetic resonance imaging, electron microscopy, and DVDs possible today. The theory of relativity, enunciated by Albert Einstein in 1905 and 1915, and value added by Georges Lemaitre, Alexander Friedman, and most recently by Kip Thorne, and many others, is what makes today's nuclear plants possible and the global positioning systems accurate. As you people know, without this celebrated theory, our GPSs would be off by 7 miles. PET scanners use Einstein's famous equation equal to mc squared for their working. Without the work of Kurt Gödel, Alan Church, Alan Turing, and John von Neumann, we would not have had computers that are so ubiquitous and so critical to our existence today. Without the celebrated theories of James Maxwell and Claude Shannon, this world would be a dark and disconnected place. Sycamore, the quantum computer from Google, which was announced a couple of weeks ago, is the result of such thinking. Unfortunately, there is no focus on such learning in India. Even before we talk about learn, unlearn, relearn, all of that, they're all excellent topics. But we first have to introduce learning in India. Most of our high school and college students learn their equations and some examples of these equations by heart, transcribe them in their examinations without understanding their applicability in new unstructured situations, get marks, pass the examination, and forget it totally. Let me tell you, these words are coming from somebody who has had the experience of testing about 2 million students in this country. Not just 100 students, more than 2 million, probably more like 2.5, 3 million. Over the last 30 years, we have tested about 2.5 to 3 million students, and in every case, the story is they got something by heart, and not every case, I would say majority of the cases. They got something, they learned something, they got something by heart, they wrote their exam, got good marks, and then they forgot about it. When I asked recently passed out graduates in computer science some simple fundamental computer science questions like P and V semaphores, which Professor Patek can attest that this is a fundamental thing like debit and credit for an accountant. When I asked these simple questions to the students, they tell me that their examinations got over a few months ago and that they have forgotten these fundamentals. This is definitely not learning. Let me now get to the problem of helping students actually learn rather than memorize. Let me stick to STEM subjects with which I am a little bit familiar. Not too much, but a little bit. The objective of science is to unravel nature. The objective of engineering and technology is to use scientific knowledge to make life of human beings more comfortable, more productive, and of course more pleasurable. That's what engineering or technology is all about. I must add that mathematics too has started adding tremendous value in unraveling nature during the last and the current century. All of you who have done string theory know that it's primarily mathematics, right? Therefore, our responsibility to our students is to help them understand the nature around us first, and then to encourage them to unravel deeper mysteries of nature. For example, our teachers must teach their children concepts in physics using natural phenomena like why the sun rises in the east, why the sun is orange early mornings and evenings, why the intensity of sound reduces as the car moves away from us, why we weigh less on moon, 1/6 on moon than on earth, why the space is black, and why rainbows happen, etc., etc., etc. There are zillions of questions. You people know better than I do. Once they understand these phenomena using theory, they must be encouraged to think for themselves and explain other natural phenomena in terms of these theories. At higher levels, they must be encouraged to use their learning to solve many of the huge problems that this country has in areas like agriculture, healthcare, education, nutrition, clean water and clean air. How do we empower our children to obtain such a mindset of problem solving in STEM subjects through learning as I defined earlier? I believe that our homes must be where our students study, and classrooms must be the place where there should be Socratic learning through collegial interaction between the teacher and the students on one hand, and among students themselves on the other hand. The focus has to be on exploration, doing experiments, reflection, discussion, self-learning, imagination, critical reasoning, curiosity, and questioning. The focus on annual examinations must cease. There should be weekly tests to eliminate the practice of students preparing only once or twice a year for examinations. After all, examinations do not come pre-announced in real life. Every day is an examination in real life. The questions in the school and college examinations must test the learnability of students rather than their ability to memorize formulae. It will be ideal if the examinations can become open book examinations and questions pertain to the nature around us and to problems in real life. I have deliberately focused on the new mindset of learning rather than learning and unlearning. If we learn how to learn, then this other issue becomes simple. And also, I think by and large, at least in science, you don't unlearn anything. When you came out with Einstein's theory of relativity, you did not say Newton was wrong. All that you said was you qualified and said, at certain velocities, what Newton said is right. At certain other velocities, at certain other masses, what Einstein said is right. So therefore, I don't know if in science there is that much of unlearning that we need to do. As new disruptions and innovations come in, the new mindset, which is full of introspection, imagination, critical reasoning, curiosity, and questioning, will automatically handle these changes successfully and make our students even better in these fast-changing situations. I wish this conference the best. Thank you very much.
Good morning, sir. My name is Dr. Bharat.
Yeah,
I have come from Hyderabad.
Yeah.
And I represent Vishwani Business School, Hyderabad. Sir, my question is with reference to this new age learners who are subjected to information overload from all corners. And then they are baffled with what to focus on and what not to focus on. And at the end, they get utterly confused. And as a professor and facilitator, we are also finding very difficult to actually channelize and then let them have the right approach towards that. And at the end, what is happening is what you just narrated, like they are just memorizing what they are thinking they should be memorizing. Thank you.
Well, you're right. I think learning is not knowledge gathering. Learning is about observation, is about doing experiments, is about critical reasoning, is about curiosity, is about using whatever one has learned to solve problems in related or unrelated fields. Therefore, I think it will be a good idea if experts in education, there is a new policy that is going to be unveiled officially soon. It has excellent people like Professor Manjul Bhargav, field medal winner. And I hope that they understand that what is needed today is for our youngsters to understand a few fundamental facts, fundamental learnings, and then use those learnings to apply, to understand nature around them, to solve problems around them. Once we start solving problems around us, then everything becomes simple. Let me give you a very simple example. I was at one of the very famous IITs a few years ago. Outside that IIT compound, it is an absolute mess. It is so much of dirt there. So when I was asked to give the convocation address, I asked them, what is the purpose of you? There are civil engineers here. You talk about environmental engineering, you talk about cleanliness. Why is it that no professor ever thought it worthwhile to have a project to get the clean and to write a body of knowledge on how to keep that environment clean? If the students of IITs, they themselves don't use that learning that they learnt in the environmental engineering class to keep their own surroundings clean, what is the value of that learning? That learning is zero. Its value is zero. So therefore, I think I agree with you that what is important is not how much you stuff into your brain, but how well you use whatever you have learned in the class. You know, I again, sorry to be taking time, but I don't know if you know, there was an Irish student called John Bell. John Bell was a postdoctoral fellow. In his postdoctoral work, he questioned Einstein's understanding of quantum mechanics. And he asked there is a very famous theorem called Bell's theorem. And he said, does the moon not exist when you are not looking at it? So the point is, that young man of 24 or 25 had the self-confidence to question Einstein. So the point I am making is that our learning should be useful to solve problems around us. Some of them will go on to fundamental research. A small percentage of our students will go on to fundamental research, and those fundamental research initiatives will eventually add value to the society. I don't know if you people have read a book called The Usefulness of Useless Knowledge by the founder of the Institute for Advanced Study at Princeton. And then later on it was regurgitated by Robert Digraph, the current director of the Institute for Advanced Study. And there he talked about how quantum mechanics, how relativity theory, etc., they have all become very, very useful. After 100 years, or near 100 years of relativity theory, we have GPSs whose accuracy is guaranteed by applying theory of relativity. We have, of course, as early as 1945, we came out with the nuclear bomb. But as you know, as early as 1980 or so, 80, 85, we came out with PET scanners, which use Einstein's E equal to mc squared. So the point I'm making is this: even those that go into fundamental research will have applications at some time or other. Edward Teller, the famous chemist who won the Nobel Prize from the UK, he said, don't call these fundamental research, call them not yet applied research. Anyway, sorry.
I am sir. I am Dr. Jagan Mohan Reddy
Yeah.
from Symbiosis Institute of Hyderabad. I have two quick questions, sir.
Yeah.
I'm a great fan of
No,
you, sir.
one at a time, because I'll forget the second one.
Okay, sir. Okay, sir. Thanks.
One at a time.
No issue, sir.
Yeah.
I keep, quoting you in my class that after 4:30, the net worth of my company is zero because my employees leave.
Yeah.
But nowadays, people are talking about artificial intelligence, machine, then augmented humanity.
Yeah.
Is there any threat to the what we call human beings and their relevance in the society?
You see, all of you have to understand one thing about artificial intelligence. So much has been made about artificial intelligence, so much has been talked as if it is manna from heaven, as it is it's the ultimate thing. No, there's one thing that no computer can ever do, that a human being can do, which is defining a goal on its own, on one's own. Therefore, human beings will continue to be relevant, human beings will thrive as long as you use your brain to define more and more aspirational goals, to define new and new way of doing things. So no artificial intelligence program can ever define a new goal on its own. So therefore, don't worry about it.
Thank you, sir.
Human beings will continue to be relevant.
Sir, my second question, sir. Since I am from a B school, most of the surveys, whether it's by Aspiring Minds or McKinsey, FICCI and all, they say that leaving IIMs and other premier B schools, only 10% of the business management graduates are employable. And one major factor being quoted is that industry institute interaction is not that much. But when I look at this Tier 2, Tier 3 B schools, sir, hardly they have any access to the industry. Of course, in Tamil Nadu, I have seen that industry institute interaction is there on the Tier 2, Tier 3 schools also. So don't you think that the industry also has a responsibility to nurture this Tier 2, Tier 3 B schools, sir?
No, I think it's not industry's responsibility. Let me take an example from nearer home. This city is supposed to produce 38% of about $125 billion of software. Some of it may be abroad, some of it may be here. But overall, they are responsible for 38 plus 1/4 of 38 is somewhere around 9.5. Therefore, this city produces $47 billion of software. But what is the contribution of Indian Institute of Science in that? It's very, very difficult to define. I don't know. I personally think it is zero, but I may be wrong. I would like to be corrected. So I spoke to my friend Balram, who used to be the director. He was my hospital mate at IIT Kanpur. So Balram is an extraordinary individual, a great researcher, all of that. He said, why don't you ask your professors to send proposals to us, looking at telling us in what way they can improve our productivity, in what way they can help us solve new problems, in what way they can help us attack new problems of our customers. So therefore, as long as your professors think carefully and suggest how the industry can become more productive, industry can grow better, that industry can solve bigger problems for our customers, I can assure you that they will all come to you. Let me give you another example. In 1997, there was a professor from a Tier 2 engineering college here, called JC in Mysore. He wrote to us, he was a professor of computer science. He said, you guys are all going to attack this Y2K problem, and I have some ideas on how I can improve your productivity. Within 24 hours, he got an invitation. We invited him, and he came and worked with us for 1 year, and finally he joined us because he was so good. So the point I'm making is this, that it is your responsibility to suggest to the industry what problems you can solve for them rather than expecting industry to invite you. Nobody will invite you because they are busy themselves. Let me give you another data point. My brother-in-law is a well-known professor of astrophysics at Caltech, and he tells me that 33% of his time goes in soliciting funds for his doctoral students, because you know in America, unless you can raise funds for your doctoral students, you can't have any doctoral students. So therefore, he is constantly in touch with NSF, he is constantly in touch with large corporations to obtain funding for his students. So therefore, unless you, the business school people, you, the technology school people, reach out to the industry and think of the problems that you can solve for them, how you can make them become more profitable, more productive, better in quality, I don't think they will be interested in you.
Good morning, sir.
Yeah.
Myself, Dr. Shyam Sundar from M. Kumarasamy College of Engineering, Karur, Tamil Nadu. Happy New Year, sir. Happy New Year to all. Thank you, sir. Sir, as per the statement by APJ Abdul Kalam, sir, in 2020, India will be the superpower. So, what is the view from...
Poor man, he is dead. Let us, yeah.
So, what is the status as per your view, sir?
No, I didn't agree with Abdul Kalam. He is a good friend. I used to tell him, Kalam, you are just making this statement. It has no relevance. It simply will. We all knew that for a country to become a developed nation, we must first change our culture. Our culture of honesty, culture of work ethic, culture of independent thinking, culture of shunning apathy. There are so many things that are cultural in this country that are preventing us from becoming a developed country. Therefore, it is very easy for us to say that we will become a developed country in 2020, 2025. All of that, they're all good to say from this. But that task is very, very hard. It's going to take a long time for us to change our culture and consequently to become a developed country. We don't have to worry about it. As long as we are making progress, as long as we are making the life of the next generation better than our own life, then it's all right. But he was a good man. Kalam was a good man, but in this particular case, he was obviously wrong.
I am Lakshman Vatawala from Sri Lanka. I am here. So,
sorry. Yeah, please.
Lakshman Vatawala from Sri Lanka.
I thought he went.
I think you mentioned very rightly of the STEM education. I think in all countries this is really one of the prime areas, especially in the school education, how to set up this STEM education. If you really see, it's mainly prevalent maybe in the rural areas where proper facilities are not available, the teachers are not available, and always it's an excuse. So what I just want to ask you is now with these new technologies and other changes that are taking place, what would be your recommendation as to how a country can quickly set up this STEM education in the different areas for the benefit of the children?
It took America about 100 years to become number one in research. As you know, in middle of the 19th century, it was Germany, it was France, it was England. They were the leaders in research. America was nowhere near that. In fact, Johns Hopkins was the first university in the US to become a research university, not even Harvard. So therefore, the task of orienting our students to become more focused on real learning, more focused on curiosity, more focused on truly understanding and applying it to other situations, to enhance curiosity, to enhance ability to do critical reasoning, all these things, they're all cultural. Cultural issues, as I pointed out earlier, takes a long time if we start that activity today. But I don't see that happening in most places. The only place where students actually study at home and come and discuss in classrooms is in business schools. Definitely at IIMs, I don't know at other places whether it happens or not. It is in these IIMs that class participation becomes very important, questioning becomes very important, and the student should have studied whatever he or she wanted in their hostel or in their home, and they come. But to bring that to our engineering schools, our science schools, science colleges, our colleges of medicine, etc., is a humongous task, and that activity is going to take a long time, but it has to be started. But I haven't seen any attempt anywhere to get to this kind of thinking. So we don't have to worry that it takes a long time, it's understandable, but let's start today. Let us get to open book examination. If you can get to open book examination in your college, and then in the classroom, make it a discussion. Let students ask questions. Sir, I studied this Castigliano's theorem. Okay, I have got this doubt. Why, under these circumstances, does it work this way or that way? Castigliano's theorem is a theorem on study of structures. Sorry, I didn't tell you that. But anyway, so the point I'm making is, let's start that kind of thinking today. Let's get to open book examinations so that students know that whatever they have learned by heart has no value. Questions will not be asked of that. But to do that, are there teachers in India or in Sri Lanka to do that? That is a big question. That is a question that we have to. Let me give you some data on the teachers. Deepak, I hope you will pardon me for this. In 2002, our selection rate of engineering college students was 1.4%. In other words, out of every 500 students that we gave our learnability test to join Infosys, only 7 students passed the test. Now it may have been diluted, now it may be very high, 10% may pass, I don't know. So I said, look, there's so many teachers who are writing to join Infosys. Why don't we give the same test to them and find out? The same test that we have given to engineering college students, we gave to teachers of engineering colleges from all over India. Fortunately, we had a very good sample. North, south, east, west, everywhere. What do you think was the success rate? It was 1/10, 0.14%. In other words, out of 5,000 teachers that took the same examination as their students, only 7 of them passed. That is the quality of teachers in second tier and third tier engineering colleges that existed in 2002. It may have improved now. I'm not going to question that. But at that time, this is, on an average, random selection. It was not any specific selection. So therefore, I would say your question would be, do we have teachers who can teach our students independent thinking, critical reasoning? I think those are the questions. Those are can they give open book examination? Can they solve those problems themselves? I think that is
This is Ashok. My name is Ashok. I am from the industry.
Yeah.
I work for Tata Consultancy Services.
wonderful.
As you have rightly said, that in the industry there is no every day is exam. When we
Yeah.
walk into when we
Exactly.
walk into client meeting or even
Yeah.
with
Exactly.
our peers, every day is
Yeah.
exam.
Yeah.
While in the colleges you
Yeah.
have exam, whether mostly summative assessment at the end of 6 months or at the end of 1 year or something.
Yes, sir.
So do you recommend, sir, that for the, especially for the professional courses, engineering, management, etc., we should move to formative assessment? So partly what you said in the in response to the last question, that every day the teacher should assess, come with the marks, and then at the end of it they give a, although there is a chance of bias getting into it, but is that what is your recommendation, sir?
No, everyday assessment is a very tough problem. You can have weekly examinations, weekly tests, but every day, like they have in business school, there is a component called class participation, CP. The student is evaluated with a certain percentage of marks set apart for class participation. So the teacher can observe, or the teaching assistants can observe and then say that, this student participated in class discussion, his questions were good, or his answers were good, his comments were good, and that can be given. But holding examinations every day for every student, particularly if you have 60 students, is almost impossible. But classes should become a discussion between the teacher. How many of you have watched Professor Michael Sandel's course on philosophy? It's an online set of courses. There are 12 lectures on ethics. I think it is on ethics. It's on YouTube under iTunes University. Please watch it. This Professor Michael Sandel is a very famous philosopher. He teaches at Harvard University. He has so many students taking his class. Actually, this is a sophomore year class. And he has about 1,000 students attending his classes on philosophy or ethics, whatever it is. Therefore, he holds it in a place called Sanders Theatre. Sanders Theatre is a theatre in Harvard, and that's where he holds his classes. And his class is a good example of Socratic questioning, Socratic learning. So therefore, all that I am suggesting is that we should give that a chance. We should see if our students can indeed absorb that. I am confident that our students can pretty quickly adjust and can perform as good as anybody else in the world if we give them opportunity to participate in discussions, in Socratic learning, in open book examination, etc., and they will start solving our problems. But if we force them to take these standard learn by rote examinations and then pass, get marks and all of that, they'll be, as you rightly pointed out, 10% of them will be usable by the industry among management graduates, and the same McKinsey study said 25% is the maximum percentage of students from engineering who are useful to the industry. That is the...
This is Abdul Rab from Dhaka, Bangladesh.
Yeah.
I will refer to your example of the civil engineering students not giving up the campus.
environmental engineering students.
Yes, environmental engineering, okay. We actually teach these students learn, acquire some knowledge, and sometimes application. But then, whether he will practice this or not depends on his attitude and behavior. Now, what is missing in our teaching is that we stop just giving them the knowledge, perhaps some encouragement to apply, but then application depends on his attitude. You know, in engineering or business or in other courses, we found that is lacking. That is why they learn but they do not practice. But I would appreciate very much.
Then there is no learning.
There is no learning. That is why
If you don't practice,
that is the
then
missing
there is
link.
no learning.
That is what the missing link. Okay. Now that needs to be emphasized in teaching learning. And then I would say that what happens when these graduates end up in your Infosys? Do you change their attitude, or at least train them to acquire the right attitude and then proceed? Do you have such training programs?
Well, we have a 8-month-long residential training program in Mysore. It's the world's largest training facility in the world. We can train on a given day 25,000 engineers. We make it extremely tough, where the whole focus is on learnability. What is learnability? As I defined earlier, it is the ability to extract generic inferences out of specific instances and using them in new, related or unrelated situations. So the whole focus at Mysore is on teaching generic principles of operating systems, generic principles of database management systems, generic principles of networking, generic principles of software engineering, etc., so that when they finish that course, they can go to any operating system, they can go to any database, they can go to any new technology and ask fundamental questions in those technologies, in those contexts, and then quickly adapt them. Just like I said, you can use Bayes' theorem to enhance the probability of it raining if it is cloudy. You can enhance the probability of fire if there is smoke, right? Like that. So therefore, our entire focus, now I don't know what it is today, I must confess, because it's more than 6 years since I left Infosys, so I would be telling you lies if I say it is so today. But definitely, as long as I was there, we made it very tough, we made it open book, we made it generic learning, we forced them to automatically think, we forced them to do critical reasoning, etc., etc.
Hi, I'm Ishansh. Hello.
Yeah, please.
I'm working currently in healthcare domain.
Yeah.
I have, as the previous question context already is said, that hey, specific knowledge is something that you gain after you go into the industry. And my question is a bit different. So given that we are in India, I have a question about, hey, if there is a ground-breaking technology and it will do good to the people, not only India, all over the world, then given that we have so much bureaucracy and so many rules, how to go about introducing it?
No, I think, sorry, I really don't want to answer that question, because now we are focusing from a topic that we were discussing, which was learning, which was how to make sure that people truly learn, etc., to bureaucracy and all of that. I think that is the standard Indian way of defocusing. I think the another day you have a conference, this is a business school, they can have on the ills of bureaucracy. There you can ask this question, not here.
Sure, no problem. Thank you.